Welcome to the Batch Reporting and Admin App screencast for the data movement topic of the vFabric reference architecture. In this screencast, we'll cover running the reporting app in the Spring Tool Suite. We'll look at some of the implementation details, the use of Spring MVC annotations to support RESTful APIs, the use of Spring data repositories, and Query DSL. In addition, we'll take a look at the Spring REST exporter as a means to automatically generate a REST API based on a Spring data repository, and the REST shell for testing REST-based APIs. And then finally look at setting up the admin application, which is based on the Spring Batch admin app in Spring Tool Suite. So our first step is to get the reporting app running in STS. So we'll deploy it to TC Server, running in STS, and then run it against some data created by the Query DSL integration test. So here I am in STS. You can see that the VFRA batch project has been imported, as well as the children projects, one of them being the VFRA batch report. I'm going to navigate to the Query DSL test and then go ahead and run this as a JUnit test. This will create some data in H2. And I'm also making sure that my TC server instance is stopped, since H2 will only allow a single connection at a time. So my test completed successfully. Now I'm going to go ahead and start up my TC server instance and then add the VFRA batch report app to that instance. Wait for that to complete. Once that's completed, I can go to my browser, paste in the URL, VFRA batch report /order/report. That'll redirect me to an HTML page, which will give me a JavaScript pop-up that shows the results of the first REST call, 3 data points that are displayed in the by order history, and then another pop-up with the data points that are shown in the sell order history. So these graphs are based on the JQplot library that's also used by the Spring Trader application. We're sending REST calls to our Spring MVC controller, returning JSON based on data in our H2 database that was created by the integration test. Now we're going to look at the reporting app implementation, starting with the client side and the order hist.html. Here's our order history HTML. It's using JQplot. As we mentioned, it's passing a URL for our REST API, which is order/history. It takes 2 parameters, a buy or sell type and a timestamp, which is the number of specific order sets that have been copied by the copy orders job to report on. So now we'll look at the Spring MVC annotation approach taken for the server implementation, in particular the use of request mapping, response body, and request param annotations. Here I am in the REST order controller. In my web.xml, I've mapped this to the URI order, and then within the controller you can see I have a order report mapping, which does the redirect, and then I also have the history mapping, which is handling the REST API call using the request param annotation to parse the type and timestamp parameters from the REST call, and then make a call to my order repository, get order history by type. And then I take the result, which is actually a list of object arrays, and return that as application JSON. I have a response body annotation, which helps converting the result type into JSON. Again, a good example of how little custom code is required to support a REST API. So now we'll take a look at our order repository implementation. So I have a custom impl class that extends Query DSL repository support and is based on the use of Query DSL, which is a API that is type safe and fluent. It's very easy to read, great alternative to building queries using string-based queries or Hibernate criteria. This is a lot more concise. Get the advantage of, within an editor, I can get auto completion. In this case, it's very simple to see that I'm doing a query from order. I'm grouping by job timestamp. I'm ordering by job timestamp and the sending order. And I have a limit clause as well. In the second statement, I'm building a where clause. And again, I get the benefits of auto completion in all of these cases. So Query DSL is based on the JPA annotation processor. It reads annotations on JPA entities and generates source that supports the auto completion I just showed. And the processor is invoked in the Maven build cycle. So in the pom.xml, I've configured under the Maven compiler plugin a plugin for generating source based on the JPA annotation processor, and it's going to be executed in the process goal of the Maven build. So this is the order entity. You can see that there are a few JPA annotations like entity, embeddable ID, embeddable. I have a composite ID, so I need to use embeddable in this case. And then based on those annotations, the JPA processor will generate the source and the target generated sources annotations, which was based on my Maven configuration. And it will generate a QOrder class to reflect the domain class, and then there's also a composite key class. So the QOrder class is actually what's used when I'm building the query and using the Fluent API. So here's QOrder, and you can see that I'm getting the order object within there, and then I'm using that within the query that I build. So we looked at the order repository custom implementation based on Query DSL. Now we're going to look at the order repository interface, which, depending on what it extends, determines which custom methods and CRUD-related methods and query-related methods are available in the interface to the application. From the Spring point of view, I'm using a repository annotation on an interface called order repository. This extends JPA repository. I specify here the domain type order and the key type, and I'm also extending Query DSL predicate executor and my custom repository interface. I've also defined a single method find by order status and quote symbol. So with Spring Data repositories, if you follow the convention of saying find by the domain type and some number of properties combined potentially with and, you can get a free finder method implemented for you. So there's a bit of Spring repository configuration which I've done in my data access infrastructure context XML file. I've included this JPA repositories element. It's going to scan this particular package, and very importantly, it will recognize my custom implementation with this suffix. So in the case of order repository, it knows to look for order repository custom impl and use that to pick up the implementation. So if I look at the Query DSL test I've implemented, you can see that I have a reference to an order repository. It's a interface reference based on the interface I defined earlier. It's auto-wired, so I'm actually getting the implementation that's generated by the framework, and I can call the finder method that I defined in the interface, so that's implemented for me. In addition, there are a number of CRUD-related methods that have been implemented for me, such as count and delete and find by and save. And in addition to that, I have some Query DSL-related methods where I can pass predicates, so I can define a predicate and easily reuse it in various ways. In addition, I see that I have my custom implementation get order history by type that has been wired in as well. Now we're going to take a look at the REST exporter and the REST shell. We'll look at the setup as well as using the REST shell to query the order APIs, both the ones made available by the REST order controller that we looked at earlier, and those made available by the Exporter API, which is based on the order repository interface. And there is a readme.txt that lists all of the REST shell commands if you want to retry them. So I need to set up the Spring Data REST exporter and the REST shell. So the Spring Data REST exporter requires this Maven dependency, which I've included in my pom.xml. And then in my web.xml, I need to define the exporter servlet, repository REST exporter servlet, and I've mapped it to order X. So I've downloaded from GitHub the REST shell from SpringSource, and I'm in the distribution. I've done a Maven install, and I'm going to run the command. I've set up my Java 7 path and Java home variables. Now I'm going to follow the particular URI for order history and issue a get command via the REST shell with those parameters, exactly what the order history graph is doing via JQplot. And you can see that I get the JSON array back that's actually displayed in the graph. So now I'll take a look at some of the methods made available via the REST exporter. So I'll navigate to the order X URI, and from there I can say list order, and this will show all of the orders available in the repository. So it's the exporter is basically issuing a find all on the order repository interface and automatically exposing that. Another thing I can do is get a specific order. And again, the exporter will convert that to a method on the order repository. One thing that was a slight complication here is I have a composite key, so I did have to configure a order key conversion service so that the REST shell could convert this string into a API call. So that concludes our review of the REST shell and the Exporter API. So a great benefit of the REST shell is it's a very concise way to interact with a REST API, and a simpler option than using curl or wget. Now we're going to look at the admin app and getting that to run in STS. We will follow these steps to set up the admin app and then quickly look at the UI. So now we're going to run the batch admin application in STS. So there's a VFRA batch admin project that's been created. It has a readme.txt which goes over the instructions I'm about to run through. First thing I want to do is update the batch default properties to use the H2 database properties, and then I am going to go to the batch core project and run the successful step test to initialize H2. I've also stopped my TC server because H2 in this embedded mode will only allow one connection at a time. So once that's complete, I can go back and start up my TC server. I've already deployed the batch admin to the TC server, so I'll just wait for that to start up. The app is started up. I've opened up a browser and I've navigated to my localhost 8080 VFRA batch admin. This shows me the main application UI. I can go to jobs and see that it does list the job that I just ran through my integration test. I can dive into that particular job, look at executions, see that it shows a status of completed, look at the details of the job. So that was a quick intro to starting the app up in STS. In the production overview screencast, I'll use this UI quite a bit to look at the results and performance numbers of running a job in different configurations. So that concludes this screencast. Thanks for watching.